So this is part 3 of the C1 21st Century Science review. So most of this has been discussed already in the previous two parts. This one is saying understand that the pollutions cannot disappear, they have to go somewhere. So this really is just a follow-up from this statement here. Understand that during the course of chemical reaction, the number of mass of each element must be the same for products as in reactants, thus conserving mass. Just as a note, this is in bold here. This indicates that the idea of conservation of mass will only come up in higher papers, but it's well worth everyone understanding that. So all this really says is that we can't create or destroy mass. It must move from one place to another. So again, because we've got 4 oxygen atoms on this side, we must have 4 on that side. 4 hydrogen atoms on this side, we must have 4 on that side. 1 carbon atom on this side, must be 1 on the other side. So although when we take a fuel like methane or a wax candle or some petrol, anything like that, and we burn it and it produces energy, it looks like it disappears. In reality, the atoms that make up the substance aren't disappearing. In this case, they are turned into gaseous products, carbon dioxide and water, and so they appear to disappear because we can't see them, but they still exist. So they've just gone up into the air. Even though they're gas, they still have mass, so they still have weight, and you will probably know the expression air pressure, and that is because of all of the particles of air which are surrounding us and impacting on us, producing atmospheric pressure. So those particles are still there. So we need to understand that they don't disappear and then just know the facts as previously. So particulate carbon can deposit on surfaces and make things appear dirty. And so it can make central London look particularly dirty, for example. Sulfur dioxide and nitrogen dioxide react with water and oxygen to produce acid which is harmful to the environment. So examples of harm to the environment, as discussed, it can lead to trees can die, and acidified water will kill wildlife. Carbon dioxide is used for plants photosynthesis, so this is a good part of burning fossil fuels. It produces carbon dioxide which we use to grow more plants, and it can also dissolve in rainwater and in the seawater, and that can lead to sedimentary rocks, and that can lead to greater growth. Okay. So part 3, choices we can make about personally, locally, nationally or globally to improve air quality. So this is where your generally where your 6-mark questions might come from, about talking about social, economic and environmental impacts of using fuels, particularly in this section. So understand how atmospheric pollution caused by power stations that burn fossil fuel can be reduced by using electricity. Well, very simply, if we use less electricity, then less fuel needs to be burnt, and therefore less CO2 released, and therefore lower global warming. Okay, and if that was a 6-mark question, describe and explain how using electricity would affect atmospheric pollution, you would be expected to be able to discuss all of those steps: less electricity, less fuel burnt, less CO2 released, less global warming, and be able to talk about each of those steps. Removing sulfur from natural gas and fuel oil, well, simply put, if there's no sulfur, then no SO2 produced. And removing sulfur dioxide and particulates from the flue gas emitted by coal-fired power stations. So you've got a choice really. If that's our block of coal, and within our block of coal we've got little bits of sulfur. It'd be better if we make that coal black, just like coal is. So we've got all these little bits of sulfur within the coal. we've got two choices really when it comes, and it might be natural gas, it might be oil when it's burnt. We've got two choices about how we get rid of this carbon dioxide. We've got pre-combustion removal and post-combustion removal. So if we remove before we burn it, then we end up with just coal, and that just leads to carbon dioxide, and the sulfur gets removed beforehand. If we don't remove the sulfur, we will burn it and we will produce sulfur dioxide, and then this sulfur dioxide is removed in the flue gases, and that's just a fancy word for the chimney. Okay, so how do we get rid of it? So if we've got our coal, for example, and we're burning it, and it's got our little bits of sulfur in there, and so we've burnt that, and the CO2 that goes up into the atmosphere, and the sulfur dioxide, which we want to get rid of. There's two ways of getting rid of it. Note here that you're not required to write word or symbol equations, you just need to understand the process. So use of alkaline slurry, so sulfur dioxide, because it's an acidic gas, it will react with alkalis, e.g. calcium oxide, to make salt and water. And then these ones can be disposed of safely. Okay, and the other way of doing it is reacting it. So that'd be one way of doing it. So react with calcium oxide, or we can take the sulfur dioxide and we can just pass it through seawater. And other chemical reactions will occur which will stop the sulfur dioxide from getting into the atmosphere. Understand the only way of producing less carbon dioxide is to burn less fossil fuels. When we burn a fossil fuel, when that's burnt, it produces CO2, and there's nothing we can do about that because fossil fuels are hydrocarbons. They're made from hydrogen and carbon. We will always get carbon dioxide and water. This is not a problem. This just goes up and makes clouds and then falls as rain eventually. This is a problem because we're increasing the amount too quickly in the atmosphere, and it's causing increased global warming. So it will always, the only way we can reduce the amount of CO2 produced is by reducing the amount of fossil fuels. If that goes down, then that goes down. But there are things we can do about that. There are modern power plants which are being created which will capture the carbon dioxide and pump it underground, pump it into old oil wells. Can be useful to get the remaining oil out of there. It can be reacted with other substances and turned back into rocks effectively. It can be piped to the bottom of oceans, but all of these are relatively new technologies and nothing works on an industrial scale yet. Ways that we can reduce atmospheric pollution from motor vehicles, so this is obviously something that everyone can make an impact on with their own particular vehicles. So you guys, when you're driving cars in 3 or 4 years time, burning less fuel. So if you've got a more efficient engine, so the modern engines can be up to 2 or 3 times more efficient than something from 10 years ago, and so simply put, you get more miles per litre. If you use low sulfur fuels, which most fuels these days are low sulfur, you can't really buy high sulfur fuels, obviously will reduce the amount of sulfur dioxide being produced. Catalytic converters, almost all cars have these days. Nitrogen monoxides, they get reduced back to oxygen, and so remember this word from previously, reduction here, it just means removal of oxygen, so it goes from nitrogen monoxide back to nitrogen. And carbon monoxide is oxidized, so we're adding oxygen, and that goes back to carbon dioxide. So not full equations here. So part C here, not full equations, but if you've got nitrogen monoxide and you've got oxygen being added to it, then that will end up removing the oxygen, so that will go back into the atmosphere as non-pollutant back into the air, and our carbon monoxide will pick up extra oxygen and end up as CO2. And that will go off into the air. So this one's obviously not a problem in the air. This one will lead to greater global warming, but it's better than carbon monoxide going into the atmosphere because this is poisonous. Adjusting the balance between public and private transport. Obviously, if we've got more people on buses, then more passenger miles per litre of fuel burnt. Obviously buses are bigger, so they require more fuel to travel per mile, but if you can get 20-30 people on that bus and it only uses 2 or 3 times the amount of fuel, then you're making a saving of 10 to 15 times in terms of the number of miles people travel. Use legal limits for exhaust emissions, which are enforced by MOT tests. So basically every year your car is checked annually, and then if your car is producing too many exhaust fumes, then it's not allowed back on the road until it's fixed. And then understand the benefits and the problems of using alternatives to fossil fuel for motoring, limited to biofuels and electricity. Obviously this is a classic 6-mark question, so advantages and disadvantages of these. So biofuels and electricity. This is again a good 6-mark question, compare and contrast the advantages and disadvantages of modern fuels. So advantages of biofuels, they're carbon neutral, would be the best advantage, so they absorb CO2 when made. Disadvantages, for example, they take up farmland from food crops, so food prices go up. And advantages of electricity, no emissions from the car, but the electricity still needs to be made somewhere, so CO2 still produced in power stations. And limited range of vehicles at the moment, although that's changing rapidly. Okay, so that's C1 all the way through. Hopefully that's useful to you. I suggest you watch this through a couple of times, make your own notes, but these are all the main statements which you're expected to be able to talk about and write about in your exam. You've got your revision guides, you've got your notes from lessons. BBC Bite Size is also a good place to have a read of, and obviously ask teachers if you've got any questions.